Okay, in our previous video we talked about scaling as a linear transform, and we saw that scaling basically is a linear transform and hence can be achievable through a matrix multiplication. In this video I'm going to actually show you an example of matrix multiplication and particularly the scaling. So let's say my original point, which is p some point is np dot array is basically some point, let's say 2 comma 4, let's say that's our point, and let's say my scaling matrix has parameters sx as 2 and sy I want scaling in x direction with 2 and scaling with y direction, let's say again with 2, just for simplicity. And now I construct my matrix, scaling matrix, let me call it as S as scaling matrix, which is, I'm calling this matrix as S. So that matrix can be constructed using NP array, let's say, and it is basically a two-dimensional matrix. So Sx, 0, and then that's the first row, and the second row is 0, sy, and if we just display this S, it is actually Sx 0, 0, sy, just like this one. So now let's transform this point P using this scaling matrix S, and let's see what happens. So P dash, let's say P dash, or the resultant point is S dot P. So that's our that's how you multiply a matrix. If you just write the static operation, it will do pointwise multiplication, not the matrix multiplication. Here we require the matrix with vector multiplication in terms of matrix multiplication, so we write a dot function here. So that's P dash. If you see P dash, it will be having two components, 4 and 8, and as you can expect, 2 is the x coordinate. It is scaled with 2 and moved to 4, and 4 is the y coordinate, and it is scaled with 2 and moved to 8. If we, for example, change the scaling factors, for example, let's say Sx is 3 and Sy is 0.5, let's say, then what will happen is this coordinate will move 3, will be scaled with 3 and will move to 6, and this 4 will be scaled by a half and will move to 2. So let's do that. That's our scaling matrix, and that's P dash. So that's a result. Don't worry about this dot. The result is a floating point number. That's why they are displaying this dot here. So you can just treat this as 6.0 or something like that. Now that's how you can scale one point using a scaling matrix. Later on we will write an algorithm or code in Python that will actually scale the whole image pixel by pixel to generate a new image. But the underlying method will be, you will be multiplying a scaling matrix with a pixel coordinate, and you will be getting the resultant coordinates. Then you will be doing something like copying the intensity at this pixel coordinate at the intensity in the resultant image at this particular location. So we will get to that in detail, but I just wanted to show you that scaling can be achieved through a matrix multiplication.